Hi guys, this is the Module 4 review video for your semester final. So Module 4 was all about matrices, and so by the end of the unit we did show you how to use your calculator on everything. So I'm going to show you kind of what we did in the middle of the unit, but don't forget you can use your calculator to check these and do make sure your math is correct. So one big thing to remember is whenever we talk about matrices, we reference them with dimensions. Remember, we do that by number of rows by the number of columns. So A in this example down below is a 2 by 2 matrix. B is a 3 by 2 matrix. And C is also a 3 by 2 matrix. Okay, so for when we're doing operations with matrices, when I add or subtract, they have to have exactly the same dimensions, same rows, same columns. When we multiply, the columns of the first matrix must match the rows of the second matrix that we're multiplying. And those remaining dimensions are actually what my solution matrix is going to be. So let's try and do A times B. So I'm looking at A is my first matrix, so there's my number of rows. B is the second matrix, there's my number of columns. Those do not match. If that happens, this operation is undefined, and we are unable to do it. Now, this one, 2b minus c. Okay, so I'm doing subtraction. B and c are exactly the same dimensions, so I can do that. Now it says do 2b, so that scalar multiplication means we're just going to double every single entry inside of matrix B. So I'm going to write that down here. So I've got 0, 2, 4, -2, -6, 5. And we're going to subtract C. So we got -3, 0, 2, 4, -1, 0. Okay, so when we subtract, we just do the corresponding entry. So I'm doing like this row 1, column 1 minus row 1, column 1. So I have 0 minus -3 is 3. Okay, 2 minus 0 is 2. 4 minus 2 is 2. -2 minus 4 is -6. -6 minus -1 is really -6 plus 1. -5. 5 minus 0 is 5. So this would be my solution. So we multiplied B by 2 by multiplying every entry by 2, and then we subtracted just by doing the corresponding entries. Okay, determinant of A. So the determinant of, I'm just going to write this. Determinant of this is AD minus BC. So we do the diagonals multiplied, and then we subtract. So for A, that would be 4 times 0 minus -2 times 1. So 0 minus -2 or 0 plus 2. So 2 is the determinant. Okay. All right, this one is asking me to do B times A. Okay, so now B is first. So if B is first, the rows match, or excuse me, the columns match the rows of A. So this one I can do. So if B is first, I'm going to do the rows of B times the columns of A. So remember, to do this multiplication, we kind of also do the corresponding entries. So I'm going to do 0 times 4. I'm going to write it out here. So we got 0 times 4 is 0, plus 1 times -2 is -2. Okay, so I've done row 1 times column 1. I'm going to now move to column 2. So now I've got 0 times 1 is 0, and 1 times 0 is also 0. Okay, so I've done row 1 times both columns, so now I'm going to move to row 2, and my answers are going to move to row 2. So we're going back to, sorry, I circled the row, it should be column. So now I'm on row 2, column 1. So row 2, column 1 means I'm moving down the row in my answer as well. So we've got -2 times 4 is 8. -1 times -2 is +2. Okay, move on to column 2. So I've got 2 times 1 is 2. -1 times 0 is 0. Okay, we finished with row 2. We now move to row 3 and back to column 1. All right, -3 times 4, -12. 5 times -2, -10. Okay, move on to column 2. Negative 3 times 1, negative 3. 5 times 0 is 0. Okay, so we're left with negative 2, 0, 10, 2, negative 22, negative 3. So this would be my answer matrix right here. All right, last thing we learned to do, you guys, was to solve a system of equations using an augmented matrix. So remember, we want every equation to be in the form x's, y's, z's equals a constant. These are already in that form, so we don't have to do any rearranging. So I'm going to create a matrix that has all the x's in the first column, y's in the second column, z's in the third, and then the constants in the fourth. So we've got 3 x's, negative 1y, no z's, and then it equals negative 1. Here I have 2x, negative 1y, 1z, and it equals 6. 1x, 4y, negative 1z equals 9. Sometimes you guys will have seen this in there as well. That's just kind of to show us where the equal sign is. Okay, so we're going to enter this matrix into a graphing calculator. Okay, sorry, I want to put that where you guys can see. Okay, so remember our matrix menu, second matrix, it's that x to the negative 1 button, okay? And then I'm going to scroll over to edit. That allows me to change the entries. This is a 3x4 matrix, so I'm just going to keep hitting enter until I get to the first row. And then I'm going to enter these numbers. Sorry, try and get that so you guys can see. Okay, so I'm going to go 3, enter, negative 1, enter, 0, enter, negative 1, enter. So now I'm on row 2. 2, negative 1, 1, 6, 1, 4, negative 1, 9. Okay, so now I'm going to RREF this guy, so I guess I'll keep that. You guys can see without the glare. There we go. Okay, so I'm going to just quit, get out of that. I'm going to go back into the matrix menu and scroll over to math. You can see there's determinant is that very first one, so I could check, did I do the determinant of this one right? I could enter that matrix in. Lots of cool things in here. Okay, anyways, I'm going to scroll down to RREF, hit enter, and then I have to say what matrix am I doing this operation to. So we're going to go back into the matrix menu one more time and just select matrix A. That's the one I just edited. And there is my solution matrix. So I'm going to write that down. So we've got 1, 0, 0, 1, 0, 1, 0, 4, 0, 0, 1, 8. So here is my solution. X is 1, Y is 4, Z is 8. So this is the ordered triple that is the solution to that system of equations. Okay, that's it for this video. Thanks for watching.